Okay, so question one, or actually this entire flashback, is asking you to predict the products for single replacement reactions. Okay, so just for single replacement reactions. Now, in order to do this, we must recall the definition of what a single replacement reaction is. So the definition of a single replacement reaction is when one element takes place of another element with a like charge. Okay, so this is when one element, so here's our one element in this example, it's going to take place of another element with its like charge. So to predict the products of a single replacement reaction, the first step we need to do is determine this guy's charge, the one that's by himself. Let's determine his charge first, because he's the one that's going to switch places with somebody else. So this is element Cl, element chlorine. And if we look for chlorine, we see it has a charge of -1. So I'll put -1 here. Now, let's look at these two elements here. I need to find their charge to determine which place chlorine is going to switch places with. Will it be Na or will it be F? So Na, if I look right here, has a charge of +1. F, on the other hand, has a charge of -1. Now, I'm not looking at the number, I'm looking at the positive or minus sign. So, in a single replacement reaction, if the element by itself has a negative charge, it's going to switch places with the element that has a negative charge. If this was a positive charge, it would switch places with the guy who has a positive charge. Okay? So, like charges switch places. So since chlorine does have a negative charge, he's going to swap places with fluorine because fluorine also has a negative charge. So that means that our products are going to be Na with Cl and then F by himself. Now, we're not done just yet. We have to remember crisscross rule and diatomics. So remember, crisscross rule is where you take the charges of these elements and you switch them to get their formula. So if Na with Cl, Na's charge that we said earlier was +1, and Cl's charge is -1. So when you switch them, remember you just bring the numbers down to be Na1, Cl1. And we don't typically show the ones, so it's just NaCl. So this guy is fine just the way he is. But that's not always going to happen, so you need to make sure you do crisscross rule to double check yourself, make sure the formula is written correctly. Now, for this guy, there's no crisscross rule because he's by himself, so we're good on that one there. But we need to make sure if he's a diatomic or not, because if he is a diatomic, naturally there would be two of him and not just one. So remember your diatomic 7, do this in a different color, is everyone in green here. And if you notice, fluorine does happen to fall in that category. So fluorine is a diatomic, therefore he would have a subscript of 2 there. You cannot just leave it as F. It has to be F2. Now that we have recalled the definition, did our crisscross rules, and checked our diatomics, we have now officially determined the products for a single replacement reaction. Now that you have learned the process, you should be able to apply this to question 1 to get the correct answer.